Okay, we're on side 2, and we're dealing with number 8 on side 2 of the test. We're solving this equation, x squared plus 8x equals negative 4, by completing the square. So we're going to use completing the square to find out what values of x make this a true statement. And so the x squared and the x term are both on the left side by themselves, which is what we want. So we don't have to do any moving around of the negative 4. And so at this point we can just go ahead and complete the square right now. And to complete the square we need to take half of the middle term and square it. So there we go. Half of 8 is 4, and we're going to square it. And then if we add 4 squared to the left side, we've got to add 4 squared to the right side in order to keep it balanced. Now we can find the, we can factor the perfect square trinomial. And if you don't understand the fast way or why factoring a perfect square trinomial works this way, then that's something you need to find a video on regarding that. But we are going to then factor this, so we take the square root of the first term, take the square root of the last term, so it's really the number that's being squared, and squaring that binomial, and that's going to equal, so negative 4 plus 16, which is 12. We're going to take the square root of both sides. It's going to be a plus or minus square root of 12. And we take the square root of this side and it becomes x plus 4. And then this is the plus or minus square root of 12. So we get x by itself by subtracting 4 from both sides. So therefore, x equals two possibilities, either negative 4 plus the square root of 12, or x will equal negative 4 minus the square root of 12. At this point, this is where, because the directions were to round answers to 2 decimal places, we need to then use a calculator to find the square root of 12. And so after you do that, you're going to find that one of these is going to equal, this one in fact, will equal negative 0.54, and this one will equal negative 7.46. So again, you use the calculator to determine that. So that's number 8. And if you were to substitute these into the original equation, it would make that true. The other note of interest, though, is we probably should change these to approximation signs, because these are going to be approximate because we had to round those answers.